The substitution method for solving a system of equations requires you to solve for one variable and then substitute that variable into the other equation. So we have 3 steps to work with when we're doing the substitution method. Step 1 is to solve one of the equations for one of its variables. Doesn't matter which equation you solve for which variable. That's up to you. Step 2 will be to substitute whatever expression you got in step 1 into the other equation and solve for the other variable. At this point, you will get a single number answer. Step 3 will be to take that single number answer, that value from step 2, and put it into the revised equation or to any of the equations from step 1 and solve. Usually the revised equation is easier, but not necessarily. By revised equation, what I mean is the equation that we got from step 1. Now, it's a lot of information to take in, so let's do some practice problems to see exactly what I mean. We are going to solve this system of equations, 2x plus 5y equals negative 5 and x plus 3y equals 3, using the substitution method. My first step will be to solve for a single variable. As I said, it does not matter which equation I use or which variable I solve for. What I usually want to do is look at both of my equations and find a variable that it would be easy to solve for. For instance, in this system, solving for this x would be easier than solving for anything else. Solving for this x would require me to divide by 2. Solving for this y would require me to divide by 5. And solving for this y would require me to divide by 3. But solving for the x that I have circled does not require me to divide by anything. So it will probably be easier to do. I'm going to take my second equation and I'm going to solve for this x. So I have x plus 3y, make that look a little bit more like a y, equals 3. That is the equation I want to solve for this x. Solving for this x means all I have to do is subtract 3y. And I'll do it from both sides because I have to. On one side, x equals. On the other side, I cannot combine 3 and negative 3y because they don't have exactly the same variables. Instead, I simply write 3 minus 3y. So I have solved for the x variable. What that means is that in the other equation, 2x plus 5y equals negative 5. Wherever I see x, right here, I can substitute in 3 minus 3y. And that's what I'm going to do. I'm going to rewrite my equation substituting in 3 minus 3y for x. So it will be 2 times 3 minus 3y plus 5y equals negative 5. So x has been replaced by what I got in the first step. Now I need to solve this equation. Since I only have y's in this equation, I should get a single number answer. I start by distributing. 2 times 3 is 6, minus 6y plus 5y equals negative 5. I can combine negative 6y and positive 5y and get negative 1y. So 6 minus 1y equals negative 5. I need to solve for y, so I will subtract 6 from both sides. Negative y equals negative 11, so y must equal 11. This thing is kind of in the way, so I'm going to scroll it down. Y equals 11. Now what that means for us is that since I know that y equals 11, I can take y and plug it back into the equation I got from step 1 and get the number for x. So I'm going to start by rewriting the equation from step 1. I will rewrite x equals 3 minus 3y. Now wherever I see y, I'm going to plug in 11 because y equals 11. X equals 3 minus 3 times 11. This is order of operations. I'll simply solve that. I have x equals 3 minus 33. So x equals negative 30. That means that the solution to this system of equations is negative 30, because that's my x value, and 11. This is a point in x, y. All of our answers should be given as a coordinate point x, y.